Hello guys, welcome back to our series on ESP-32 using ESP-IDF. So today's video will be on OTA, that is over the air update. But in this video, we will not understand about how the OTA code flow works, how to configure the SDK config, how to use the partition table that I have already covered in the previous video. I will share the link in the description. You can check out that video. In this video, we will talk about how to configure the OTA server. So I have got a lot of comments and mails for this to how to configure the OTA server. So we will be configuring a Python server that is already given by the ESP-IDF. I will guide you on how to create the certificate and key, how to start the server. It will be an HTTPS server. The server will be hosting the .bin file, the OTA file, and later using this advanced HTTPS OTA code and ESP32S3 device, we will download this .bin file from that server and perform the OTA. And we will also see some failure scenarios as well. So stay tuned and let's. So let us see where this Python server script is given by the ESP-IDF. Go into Expressive folder, frameworks, ESP-IDF version, example, system, OTA, simple OTA example, and this is the Python server script that is given by the ESP-IDF. So the first step will be to create the certificate and key for this server that we will start. So for that, we will be using openssl command. Press Windows R, CMD. We have opened the command prompt. So this is that openssl command that will create the key and certificate for us. I will paste this command in the description. You can copy it from there. Just hit enter. So no such directory found. So there are some package issue as we are using this Windows command prompt. So I would request you to download WSL, Windows Subsystem for Linux or Ubuntu. So there are two ways you can download. First is using this Windows command prompt. Just type one command to download the WSL. So if you enter this command and hit enter, the WSL will be downloaded. It will take some time. Or the second way to download WS or Ubuntu WSL or Ubuntu is just go to search, Microsoft Store. Here you can enter Ubuntu. Okay, so you'll get all this version. So we are using this 20.04. You can click here. I have already installed. So here you will get the get option. Once you click on the get option, it will download for you. So I have already downloaded the WSL. So once your WSL is downloaded by any of the method, we will create a folder in which we will have our certificates and the bin file. I am creating a new folder here. I will rename it as OTA server. We'll copy the path here for the server. So just go to that server path. We are in our OTA server. Now we'll open WSL here. Just type WSL and hit enter. So your WSL is open at this OTA server path. Now at this path, first step what we need the key and the certificates. This is the command, enter. So it will ask for few things like a country name, where the city name, state name, your organization name and all. So you can either keep it blank or you can randomly write anything. Okay. For this common name, this one is important. We need to give the IP address of our desktop. How to get the IP address? Just open a new command prompt here. Type ipconfig enter. This IPv4 address, this address you need to add here. So just copy this address in common name, just paste it here and hit enter. Email I will keep blank, enter. So now our CA key and CA certificate is generated at which location? OTA server. See, this is our OTA server folder. The CA certificate and CA key are generated. Now the second thing we need is the binary file, the bin file that will be used, that will be hosted on the server, which will be used by our ESP-S3 device to download. So I'm using hello world example here, just a simple example. I will build this hello world. So build is required. So we will get a bin file in this build folder. So our build for this hello world is completed. Here is our hello world project. Inside this is the build and a .bin file. This hello world.bin file, it is generated. So what we need here is the complete build folder. So we'll copy this build folder, go to this OTA server. So we have pasted the build file here and we have generated this certificate and key. So this is all we need to start the server using the Python script that I showed previously. So now to start the server, just double click on this ESP-IDF 5.3 command. Okay, now we will navigate to the OTA server section here. Copy this path in this ESP-IDF command prompt, cd, paste it here. So now, as we want to start the OTA server using that the certificates and the build that is inside this OTA server folder, that's why we have navigated here first. Now here we'll enter the command to start the server. It's Python. Then we have to give the Python script path. This is the script. Just copy this path, paste it after Python backslash and this is the Python server script. Give a space, enter build 8070, that is the port, and hit enter. Okay, so it is showing an error that module not found, that is pexpect, this module. So there are some packages required for this server script to execute. So where these packages are stored and how to execute it, I will just tell you now. In this ESP-IDF version, go to tools. Here it is requirements folder. So we are using PyTest here. If we open this requirement, Python package is required for PyTest in ESP-IDF. This feature can be enabled by running install.either sh-bat ps1 fish and this command enable-pytest. This will enable all the packages that are required to run this PyTest. So PyTest is nothing but that is the test script that is provided by the ESP-IDF for different components, like OTA is one of them. So for other components also, they have also provided some script for testing. So let us run this command. So install.bat you will get in this ESP-IDF version, this folder. Here it is. Let us copy this path. ESP-IDF 5.3 command, go here. You have to change the directory. Let's go to this path. Install.bat. enable-pytest. Okay, hit enter. So it will download and install all the supporting packages that are required for this PyTest. It will take some time. So now the PyTest is enabled. So we'll again go to our OTA server folder. Okay, we'll change the directory here and let us try to start the server now. Okay, this was the command for the Python server. I will paste all the commands in the description. You can just copy it from there. Just enter. So the reason that we are getting this error is because at this location where our PyTest sample OTA server script is there, here. So this server script is actually looking for a build folder, which is not here. That is why it is giving this error. So what we will do is we'll simply copy this, go to our OTA server folder, okay, and paste it here. Second thing we have to do is certificate and key. We will cut this from here and we'll paste it inside the build folder. Or you can directly use this build folder. You can browse this build folder and generate this certificate here itself inside the build folder. So now let us try if this works. This will be our command. So inside the OTA server, we have already pasted this Python script. Just hit enter. Okay. So now the server has started. The server side is completed. Now we will see how this .bin file, that is hello world.bin file, is downloaded using OTA in our ESP32 S3 device. Okay, so for that we will be using this advanced HTTPS OTA example. Inside this server certs folder, we have to paste the generated certificate that is there in our OTA server build directory. Right, we have to copy those certificate and we have to paste here because the certificate validation will be done while during this HTTP request for OTA. Right, so first we will do that. Certificate and key, copy it from here. This workspace here, I have advanced HTTPS OTA. Inside this server certs, we will paste these two files. So usually only this certificate file is used. Key is optional here. So for OTA update, only this certificate file is validated with the server. This is the one change that we have to do. And see, in both the files are reflecting here when we refresh it. And second thing is inside this cmacklist.txt file, we have to add the project version here because the hello world project that we build, it is built with the default version, and if we build this also with the default version, then there will be version verification will be there, and if the versions are same, the OTA will fail. So to avoid that, we have to add this version here. So let us give it 1.0.1. So next thing is just open SDK config here. So here we have to provide the bin file URL. For that, this is the firmware upgrade URL in example configuration. This IP address will be your desktop IP address that we have entered here while creating this certificate. So just copy this IP address, paste it here. Port is correct, and the last will be the file name, helloworld.bin. So in our OTA server build, here is the helloworld.bin file. If you have some other file name, you can change the file name there. But for now, the file name is same. So we will keep it as it is. And second change will be this example connection configuration. Here you have to enter your SSID and password. These are all changes we have to do before we flash this advanced HTTPS OTA code into our S3 device. So now we are ready to flash the code to our device. Okay, so now OTA is finished. It is rebooted, and the hello world code is executing now. It is too fast because the hello world code is very small, so it is downloaded quickly. So we'll just go through the logs. So here it is connecting to the Wi-Fi. Once the Wi-Fi connection is done, starting OTA. So OTA is finished here. Upgrade successfully, rebooting. After rebooting, you can see, okay, after the device has been reboot, the hello world code is executed. So if you go here, see, we can see the HTTP GET request for hello world.bin file has been received. Whenever a device sends a OTA request to this server, this GET request will be displayed here. This is the IP address of our ESP-32 S3 device. Now, second thing to check is we want to verify that is it really checking the certificates that we are creating. This time we will create wrong certificates. So the certificates for at both the end will be different. The server certificate will be different and the device ESP device certificate will be different. And in this case, the OTA should fail due to certificate validation. So let's check this scenario as well. Yes, so we are already in this OTA server build folder. Now let us run this openssl command. So every time before running this command, do check this IP address, because if your device gets disconnected from the Wi-Fi and then connects again, then due to dynamic IP, it can change every time. So this needs to be checked before running this command. Yeah, so new certificates are created at this time. So now let us compare both the certificate, the one that is on the server and the one that is in the code. Let's just open it in Notepad. This is the server one and this is the advanced HTTPS OTA. Let us compare these two files. Yeah, so there both the certificates are different. So now we'll check this scenario. So again, I will flash this OTA code into our S3 device because the hello world code is currently after the OTA. So let us flash and check. Yeah, before that, I will just stop this server. It is using Control V. Okay, and I will run it again. Connecting to Wi-Fi. SSL handshake. So means there is a certificate issue. The certificate validation fails and the OTA begin will fail. So in next video, we will see one more concept of OTA, that is the anti-rollback. So if you find this video helpful, do like and share this video and don't forget to subscribe our channel. Thank you.